Hey everybody, quick update on my project to make an Aeropress coffee maker presser that's automatic. One note on my eye, I got hit by a Frisbee on the weekend and now I have a black eye. Fun fact, Aeropress, or Aerobi, the company that makes Aeropresses, makes lots of Frisbee type toys as well. I was not hit by an Aerobi flying disc. But still, Aeropress, love this coffee maker, use it all the time. If you haven't used one before, it's kind of cool. It's like kind of like a syringe. So we got this plunger in here, and you have a filter. Comes with a paper filter by default. You put in a filter holder and lock it on. Some people have created stainless steel mesh filters and other things like that. So, and you can load the thing from the top, on top of your coffee cup with coffee, and then add water, stir, and brew. Or you can do what a lot of folks do, which is called the upside down method. And a lot of folks like this, they load it up like that, put your coffee in your water and stir, and then you can really control the amount of time that it sits there before it starts dripping through the filter. So anyhow, I'm gonna make a coffee really quick. Let me just turn this down a little bit. I've got my gear here. I have some ground coffee close at hand. And there we go. I'm going to try and make a coffee. I'm waiting on pneumatic cylinder. So pneumatic cylinder sounded amazing to me. I loved seeing Mark use it and watched a bunch of videos subsequently. Now I understand how all those haunted house things worked in the past. So I've got my water boiler here. But that pneumatic cylinder is not here yet. So I am going to try one of the other, prototype, one of the other approaches that was on my list. So I had in there things like pneumatic cylinder or linear actuator, which is like a motor, linear kind of motor type approach, or using even like a lever maybe that would push it down for me. I've also thought about like how old-timey espresso machines that use a lever instead of just clicking a button. In that they stretch some or compress some very powerful springs, and then when you let go of the lever, it pushes down and then the water pressure resists it. I thought that'd be a little dangerous for this application. I want something a lot more controlled. And just grab my coffee cup that I'm gonna use here really quick. The other thing I thought was, could use gravity as the basic approach. So I'm going to do a little gravity method here. And it also speaks to a question I had in an experiment about how much force does it require in order to brew a cup of coffee. And so I have here a 35-pound kettlebell. I'm going to set this on top and see, actually that's really heavy. I'm going to set that on top and see if it will brew for us without hopefully dropping this on the countertop either. So I'm just giving it a little bit of support to keep it aligned and straight, but now at this point I'm just keeping it from falling off the sides. And it seems I'm not pushing down at all. And this kind of goes along with, I took some measurements on a bathroom scale to try and see how much force was required. And it felt like it was somewhere between like 30 and 50 pounds. And so this 35-pound approach works really well. The story was that I had kind of hurt my elbow, a little tennis elbow, and so pushing it myself, was painful. And so I was trying this other method, some other methods. So, I mean, if I could pick up the kettlebell and put it on top, then I guess that would be, a method. Because it did depress everything all the way down. You can see there's like some coffee That's the coffee that got compressed there at the bottom. And I've got a nice, cup of coffee here. Is it very controllable? I mean, I could use different weights. I could try a 40 pound or, 45 pound and see if we got different results or if one was better than the other. That would be an approach that we could take. Another approach, what I'm thinking to do with the pneumatic cylinder is to actually have, there's these needle valves you can use on both either on the line that's going to the cylinder to either extend it or retract it, or on the exhaust ports, because the air kind of goes to the cylinder and then goes all the way back and exhausts. And so by turning these valves down, you can restrict the airflow, and by restricting the airflow, you control the speed at which the cylinder is traveling. So it should still, it'll generate, probably up to the max force required, but by and it'll generate ultimately its max force. So that's an approach to get the speed controlled. You can also control for the overall force by controlling the air pressure. Of course, the diameter of the cylinder is and the piston on the cylinder is fixed, but I think the force is proportional or equal to the area of that piston, the effective area of that piston, times the air pressure. And so by just, since we'll have a fixed size, modifying the air pressure. So I have an air pressure regulator that's coming as well. And that will give me another adjustability point. So I could adjust speed and pressure, one would think. So I'm hoping in my final build to have something that you can really dial in and get repeatable results with. But we'll see. So thanks for watching. Take care.